In today's lesson, we'll be learning how to find the point of intersection with the method of elimination. The first step is to stack the equations on top of each other in standard form. I've already done that. You want to make sure that like terms are aligned, and you can see that. The x's are in the same column, the y's are in the same column, and the constants are in the same column. We want the coefficients of x or y to be the same. Over here, the coefficient of x is 6, and the coefficient of x down here is 3. They're not the same. And over here, the coefficient of y is 5, and the coefficient of y down here is -4. They're not the same as well. However, we want to change one of these equations, or both of these equations, so that a coefficient is the same. I'm going to try to make these two coefficients exactly the same. They're currently not, but what I can do is I can multiply 3 by 2, and that becomes 6. However, if I multiply this by 2, I have to multiply everything else in that equation by 2. That means the blue equation now becomes 6x minus 8y is equal to 12. In our next step, we want to add or subtract these equations to eliminate a variable. So over here, if we add these two equations, 6x plus 6x, that gives me 12x. And if I go positive 5y plus negative 8y, that gives me negative 3y. And 12 plus 12 gives me 24. As you can see here, nothing has been eliminated. The x variable and the y variables are still there, so that means we're probably going to have to try to subtract these equations. If you look down below, 6x subtract 6x, that becomes 0x, which is just 0, so we've eliminated that variable. Next, we have positive 5y subtract negative 8y. That actually becomes 13y. And over here we have 12 subtract 12. That just becomes 0. To solve this equation, we divide both sides by 13. These 13s cancel out, and y is just equal to 0. In our next step, we want to substitute our known variable, which is y equals 0. We figured that out in our previous step, into any equation and solve for the other unknown variable. You can use either equation, it doesn't really matter. I'm going to be using the red equation here, so I'm going to copy it down. Then afterwards, I'm going to substitute in my known value. So if I know y is 0, I'm going to replace that with 0 in brackets. 5 times 0 just becomes 0, so it basically disappears. You don't have to write anything down. So the 6x stays the same, and the positive 12 on the other side stays the same. This is a very simple equation to solve. You divide both sides by 6. These numbers cancel out, and x is just equal to 2. Therefore, we think the solution, the point of intersection to our linear system, could be positive 2 and 0. But you need to do a left side, right side check to verify this. Starting with my red equation, I'm going to copy down the left side, which is 6x plus 5y. I'm going to replace the variable of x with the number 2, and I'm going to replace the variable of y with 0. 6 times 2 is 12, and 5 times 0 is 0, so that basically disappears. On the right side, we already have the number 12, so as you can see, the left side is equal to the right side. And we're going to repeat that same process with the blue equation. On the left side, we have 3x minus 4y. I'm going to replace x with the value of 2, and I'm going to replace y with the value of 0. 3 times 2 is 6, and 4 times 0 is 0, so we don't even have to write that in. On the right side, we have the value of 6, and as you can see, left side is equal to the right side. So in conclusion, since the left side is equal to the right side, therefore the solution to this linear system, this point of intersection, is indeed positive 2 and 0.